Okay, in this video we're going to talk about how to graph a polynomial. So first of all, we're going to use the degree and the lead coefficient to find the end behavior like we discussed in the previous video. Then we're going to factor, and then we'll find the x-intercepts and use the x-intercepts to determine when the graph is positive, or meaning above the x-axis, versus when it's negative. So let's just start with running through the example. So let's look at this example. So our degree is 4. Our lead coefficient is 1, which is a positive number. And so that means our outside shape is going to be the same as an x squared graph or an x to the fourth graph. It's going to look like this one. So it's going to go on the outside edges, up and to the right, and up and to the left. Okay, so that's our end behavior. It's up and left, up and right. We'll come back to that. Step 2, factor. Conveniently, this one has already been factored, so I don't have to do anything. Step 3, find the x-intercepts. Okay, so that's where we set each individual factor equal to 0. So either x squared is equal to 0, or x plus 3 is equal to 0, or x minus 2 is equal to 0. And so if we solve each of those, we get x is 2, x is negative 3, and taking a square root, x is equal to 0. So we have 3 x-intercepts. Okay, step 4, determine when the graph is greater than 0. And because of the order that we did the material in, we've already talked about polynomial inequality. So if I asked you to solve x squared times x plus 3 times x minus 2 greater than 0, we know what we're supposed to do. We find the x-intercepts. We use those numbers to break the number line. And so we will break the number line into 4 pieces. Left of negative 3, between negative 3 and 0, between 0 and 2, and right of 2. And then our strategy was pick a number in each interval and see if the polynomial is positive or negative. So I'll pick x equals 3 as my number in the rightmost region. So that would be 3 squared, 3 plus 3, and 3 minus 2, which would be a 9 times 6 times a positive 1, which is a positive 54. And so we get a positive answer. And I foolishly didn't leave myself enough room to work here, but that's okay. We'll figure out a way. Let's see. So my favorite number between 0 and 2, my favorite number in this interval is going to be x is 1. And when I plug that in, we have 1 squared, 1 plus 3, and 1 minus 2. Running low on room. But again, we've talked about this before. I don't really care what my answer is, just whether it's a positive or negative. Sure, it would be more accurate if I use the 0.354 in my graph, but just having 3 is giving me a positive answer is going to be good enough. So let's see. 1 squared is a positive number. 1 plus 3 is a positive number. 1 minus 2 is a negative number. And then if you multiply a positive times a negative, you're going to end up with a negative answer. We do the same thing for negative 1. Negative 1 squared would be positive. Negative 1 plus 3 is positive. Negative 1 minus 2 is negative, and so our answer is negative. And same thing again for a number left of minus 3. I'll pick minus 4. And so we have minus 4 squared, minus 4 plus 3, and minus 4 minus 2. That's a negative number. That's a negative number. A negative number squared is positive. And so 2 negatives would cancel out and give me a plus. Okay, so this is actually really important. This tells us when the graph is going to spit out positive points and when it's going to spit out negative points, which is telling us when the graph is going to be above or below the x-axis. So right under here, let me see if I can draw my graph. So 1, 2. Okay, so let's see if we can slowly put all the pieces of information into the graph. So let's see, where do we want to start? So end behavior, we're going to go up and left and up and right. So I don't know, let's just draw up and left and up and right. Okay, we have x-intercepts at 0, -3, and 2. So that's where we're actually hitting the x-axis. And we determined that in different regions we have positive numbers versus negative numbers. In this left region, we're always getting positive numbers. So that means my graph is always going to have positive heights. So I can actually connect the dots here on how we're going to go from this end behavior going up and left to this dot at -3. And then in the second region between -3 and 0, we got a negative answer at -1. And so we'll have some kind of negative point. I will just draw some negative points to connect the dots. From 0 to 2, we're supposed to get more negative points. And then from 2 to the right, we're supposed to get positive points. And so we just play a game of connecting the dots. Okay, so let me go back and talk about this. There's a couple of problems with this graph. I think this is probably a decent first sketch, but if we did want to be more accurate, polynomials don't have corners. The way I drew this, it seems like it has a sharp corner right there. So if I wanted to do a better job, I would maybe exaggerate the curve slightly so that it kind of came in to 0 and just kind of bounced smoothly. But that's kind of quibbling detail. Something that's a little more important, but that I still don't worry too much about, is how exactly high are these humps and how steep should these sides be. Probably these are a little too wide and these are a little too low. I haven't even labeled my y-axis. I'm not going to stress about that. If I wanted to be more accurate, all I would have to do is plug in some more points. Like instead of just getting a negative answer for -1, if I knew which negative answer, that would tell me exactly what height the point would be. But as far as I'm concerned, I think this is a decent graph of the polynomial x⁴ plus x³ minus 6x².